How do epigenetic changes influence osteoarthritis susceptibility? Imagine your joints as busy cities where countless genes work together to keep everything running smoothly. Now, think of epigenetic changes as traffic signals that control when and how these genes are active. These signals don't change the actual city map, which is your DNA, but they influence how the roads are used. This is how epigenetics can affect your risk of developing osteoarthritis, a common joint condition. Epigenetic changes impact osteoarthritis susceptibility by turning certain genes on or off in joint tissues. These changes happen without altering the DNA sequence itself. They control key molecules involved in keeping cartilage healthy, fighting inflammation, and repairing tissue. When these signals go awry, they can make joints more prone to damage and degeneration. One major way this happens is through DNA methylation. This process adds tiny chemical groups called methyl groups to DNA. If methylation occurs in the wrong places, it can silence genes that protect cartilage or activate genes that cause inflammation. For example, abnormal methylation of genes involved in collagen production or growth factors, like transforming growth factor beta-1, can weaken cartilage and increase the risk of osteoarthritis. Histone modifications are another mechanism. Histones are proteins around which DNA wraps. Chemical changes to these histones, such as methylation or acetylation, can make genes more or less accessible. If protective genes like SOX9, which helps cartilage cells survive, become less accessible due to histone modifications, cartilage can break down faster. Environmental factors like aging, obesity, or joint injuries can also influence epigenetic patterns. These factors can trigger changes that alter gene activity, making some people more susceptible to osteoarthritis even if they have a genetic predisposition. It's like environmental signals that turn certain genes on or off, shaping individual risk. Epigenetic changes can also ramp up inflammatory pathways. They can increase the production of molecules that promote inflammation and enzymes that break down cartilage. This ongoing inflammation can lead to chronic joint damage and worsening symptoms over time. Scientists are now working on identifying specific epigenetic markers linked to osteoarthritis. These markers could serve as early warning signs or targets for new treatments. Future therapies might aim to reverse harmful epigenetic changes, helping to preserve cartilage, reduce inflammation, and slow disease progression. Understanding how epigenetic changes influence osteoarthritis highlights the importance of managing environmental risks. Maintaining a healthy weight, staying active, and avoiding joint injuries can help prevent harmful epigenetic modifications. Looking ahead, research into epigenetic therapies offers hope for long-term management and better quality of life for people living with osteoarthritis.